Everyone, I hope you're having an amazing day. This is Karan here, so I've got the opportunity to present here on Android application pen testing. I hope everyone can hear me. Before I start, I just want to thank our organizers. They've done an awesome job putting everything together, so I guess they definitely deserve a pat on the back. So in this talk, I don't want to really bore you, but I would really want to keep it not really short, but I want to keep it interesting. So in this talk, I will be covering Android application pen testing. You will see me talking about all the tools that I use on a daily basis, and some of the things that you can probably take away from this talk would be probably a methodology which you can use, when you encounter Android applications, or when you perform your Android application pen testing, right? So yeah, so let's get into it. Who am I? I'm a pen tester by day. I do bug hunting on part-time basis. I've done offensive security web expert. I'm OSCP certified and other certificates. My passion is for web and mobile applications. From last couple of years, I've started to focus more into automating in security. So that's why you see DevSecOps there. Also, I love auditing code, especially Java and PHP. So yeah, so that's another thing that I'm passionate about. In my free time, I like to play soccer and table tennis. And you can follow me on my YouTube channel, and on my Twitter handle is there. Cool. Just a quick disclaimer before I kick off the talk. Look, whatever I'm going to cover in this presentation is solely for educational purpose only. Obviously, I take no responsibility how you, choose to utilize the information that I'm going to share with you in the slides. So it's entirely up to you. But again, I would just tell you, stick to white hat, be a responsible person, and just be kind to each other, right? So yeah, so let's start. So agenda of today's talk is I will go through Android crash course, because obviously this is really important before you get into Android application pen testing. You need to understand all the important components of Android. Then we will look at what are the different type of analysis of Android application. We will talk about static analysis and dynamic analysis. Once we cover these two topics, I've just sort of put together this another section here, which is around further learnings and paths. So that means what else can you do, or how could you self-study if you want to learn more and want to do more into Android application pen testing space. So this section is solely focused on that. I also provide very useful links as well that you can probably browse in your free time. And the last section, I focused more on the developers and for blue teamers, like what kind of defenses they can put in place for their mobile applications. So when they publish their apps on app stores, what kind of controls they can have so they can make a life harder for a hacker or someone who's trying to do a pen testing on their mobile apps. So with this in mind, let's start with Android crash course. So Android, when we talk about Android application, the application package comes in APK. So the extension of the Android application is .apk file, stands for Android package. It is similar to your .exe file on Windows. In simpler terms, it's just a zip file. So if you run unzip command against your Android application, or once you have the APK file, you could simply browse the contents of the file. It will just give you, it will just unzip the contents, and you can see everything that's available within a zip within that APK file. So this is obviously the key component, right? That's what APK file is. So APK file contains all the resources your source code and all the images and like the and all other bitmaps and things like that in this package. So the key components of APK files are, I've listed them here. So first one is the Android manifest file. The second one is Classes.dex file, resources file, res file, and META-INF file. What I will do now, I'll just go one by one through each of the component. This is really important for you to understand, because if you encounter Android application pen testing, you want to make sure that your basics are clear. Right, so let's look into what an Android manifest file is. So Android manifest file is the key component of any Android application. So this file is with XML extension, looks like this when you open it. So it has everything that your app needs to run. So all the permissions that your app would need are listed within the Android manifest file. All the activities, all the content providers, all the services, all the intents that your app would need to run are listed under your Android manifest file as well. Also, what is the version of the Android API that your app is going to use is also listed in Android manifest file. We will talk about activities, broadcast receivers, services, and content providers in upcoming slides. So yeah, just keep that in mind, that your Android manifest file is really, really important. So next file we're going to talk about is the Classes.dex file. So the dex format is sort of stands for Dalvik executable format. So the dex code that your app is compiled in can be further decompiled in the Java source code. So when you want to review the source code of your application, you would have to convert the dex format into either jar or maybe like in a class format, so you could actually open that source code in tools like JDGUI or JetX. The res folder, which is the that you would see once you unzip the APK file, has all the device configurations, bitmaps, and layouts. And another component is resources.arc files. It has all the binaries of your compiled components, and also holds all the images, strings, and all other important things that your app would need when the app runs. The meta-inf folder in your APK file sort of holds the integrity check for all of the files that are in your APK. So it's pretty much like the hashes of your other files. I'm not going to go into too much detail of like how meta-inf signs all of these files. If you are interested in that, I'd highly recommend you go to Google's Android project, and they have like a really nice blog on how to do these things. I mean, how to sort of learn about like, you know, how you could actually sign these files and get the integrity check. Okay. Oh, demo time. Cool. So what I'm going to do now, I'm just going to quickly show you. I'm going to have an APK file, just which I pulled off from the internet. It's a intentionally vulnerable application. And I'm just going to show you quickly what I've just talked about. So with that in mind, let me show you my screen. Okay. Let me quickly increase the font size so everyone can see it. Oh, just gonna suck at it now. Oh wait, I can just simply zoom in, can't I? Okay, what's going on? Right, okay. So I think I have a folder here. Okay, so I've got these two apps listed here, but I'm only gonna use this one for now. So this is the APK file. As I said, your APK file is simply a zipped file, right? So let's run an unzip command against this APK, and let's see what happens. Okay, so looks like it has extracted it. So let's list the components that it has extracted. Look, as you can see, It has extracted Android manifest file. There is another folder that it has extracted, assets, Classes.dex, META-INF, res, and resources.arsc, right? So see how simple is that? So you could just simply run an unzip command and it would unzip all the contents of the APK. But what's going to happen is if I try to open, say, to read Android manifest file, let's see what happens. Look, I can't read it because I can still read it, but it's not like a fully readable file if I scroll up and down because it's not decompiled. It's not decompiled properly. All we have done is we have simply just ran an unzip command and it just listed all the components of the APK file. In order for us to achieve the readability of these files, we need to run, or we need tools that could take an APK file and they can do decompilation of the APK. So for that, so what sort of tools we need to use? Well, we have heaps of tools available, on our disposal. We could use the best tool that we could use for this job to decompile an APK is an APK tool, free tool, open source tool, perhaps comes pre-installed with Kali Linux. And yeah, you just simply feed your APK file to it, and then it will simply decompile it. And then you could go in and you can read these files. Similarly, there's another tool available called JetX and JD GUI. So these two tools are pretty similar, but JetX has more capability or has more refined search capability. And then we've got an ADB. So ADB comes pre-installed with your Android packages or Android Studio if you install on your operating system. It stands for Android Debug Bridge, sort of acts as a command line interface between your laptop and your mobile device, so you can interact with your mobile device activities and things like that using your ADB. Yeah, so another one is grep. So say, for example, you have decompiled your APK, so you have like all the files that you need. You can simply now run your grep commands and grep searches against that APK folder to see, if you could find any hard-coded information. Because in static analysis, just to reiterate, so in static analysis, you don't have to run the app. You're not changing the behavior of the app. All you're trying to do with static analysis is either trying to read the code that you've decompiled and trying to find vulnerabilities that way, or you may be looking for hard-coded secrets, hard-coded API keys, or some other sensitive information that is probably developers left in the APK file. And the last tool that I want to talk about is MobSF, which stands for Mobile Security Framework. This tool is really, really good. I mean, if you just want like a quick analysis of your APK file, the guys have done an awesome job. It's a very active project on GitHub. Links are provided in the references section as well. So this tool. I will show you. I will demonstrate this to you. So this tool will has like a drag and drop feature. So you just drop your APK file into this tool and it does all the static analysis for you. And we will see that in action shortly. Right, so let's look at APK tool quickly and let's see how we could decompile an APK using APK tool. All right, so again, please excuse my clutter here, but then we are going to use the same APK file that we used previously, and now we're going to run APK tool against it. This is probably the first tool that I've come across that doesn't use the dash next to its switch. So as I said, APK tool is pretty simple. So D stands for decompile, and then we need to give the name of the APK, which is this is the APK that we want to use. And as I said, this is an intentional vulnerable application. There are like hundreds of these intentional vulnerable application projects on GitHub, which you can use for your practices as well. So let's run APK tool and let it decompile. Cool. So look, our APK has been decompiled. Hopefully it would have created a new folder for us. Let's see. There you go. So our decompiled code is sitting in this folder. So let's go in that folder. So let's see what's inside. Okay. So as you can see, perhaps we are not seeing some code. Maybe we're not seeing Classes.dex code here, but then what you're seeing here is the decompiled version of your APK. Now, if my theory is correct, I should be able to open this Android manifest file in a readable format this time. Okay, let's try. There you go. So, as I said, now you can see and you can pretty much make sense of this XML file. In the very beginning of the talk, I was talking about, your Android manifest file has everything that your app needs to run. Similarly, you can see it here. All the permissions that your app would need are listed here. For example, this app needs access to get accounts, read profile, read context, and all other type of permissions. And then your application here also highlights what sort of activities your app has. So this section of the XML file talks about the activities. Don't worry if you don't know what activities are. We are going to cover what activities are in upcoming slides. But just keep in mind that everything is now readable. And all we did was we just simply ran APK tool and we just passed the APK file to it, and then we could see all the decompiled code, right? As I said, let's look. Another tool that I wanted to show you guys was the MobSF. So let me just quickly start the Docker container for it. So I'm just running MobSF in my Docker. They have a Docker container, so you could just simply run MobSF in Docker. It's so simple, to be honest, because I used this tool in the past. From last couple of years, I've been using it. Before Docker support, I had to install so many dependencies and whatnot, and it was always erroring out like on startup. So since they've introduced the Docker image for it, it's pretty simple. Okay, so as I said, it's drag and drop. So I'm just gonna quickly drop the same APK file that I used for the previous testing. So let's see. Simply drag and drop. It's uploading. Let's see what's happening behind the scenes. So this is what's going on behind the scenes when the tool is running. So it's doing exactly the same things that probably what APK tool is doing, but then it's just sort of taking it up a notch and trying to do further things like trying to grep for things like, maybe hard-coded API keys, hard-coded passwords, and things like that, and converting the DEX code into Smiley code, converting the DEX code into the classes form, so we could actually read the code if you really want to. And see, it's already done. This is like the quickest static analysis that you can do using MobSF, which is which stands for Mobile Application Security Framework. So here, the first thing you probably want to look at, okay, probably what the security score is. So it says 10 out of 100. Well, we probably know because it's already intentional vulnerable application. And some important information as well. Probably the name, maybe the size of the APK, some hashes here, and then some more information about the APK, the package name. Again, it's like in the Java class format that they use. The main activity, SDK that is targeted, minimum support for that, and things like that. And you can see if anything, like, you have any exported activity here, you have any exported services here, any exported broadcast receivers or exported content providers. So again, don't worry if you don't know what those things are. I'm going to cover those in the upcoming slides. But then again, you can see, it's pretty readable and very nice looking report. But then again, don't just simply rely on this tool, because obviously it's going to have quite a few false positives. And this is something you're going to learn over time, by looking at the code, by looking from your experience as well, that whether you should report these issues, to your client if you're doing a pen testing, or if you're doing bug hunting, then perhaps you want to look, more deeply into it to see whether it's a P5 or a P4, or could be I don't know, like you just want to look more deeply before you start reporting these false positives. You can see, all the permissions are listed here, and it's similar to what we have covered in the Android manifest file. This tool probably would, by default, highlight everything as dangerous, like things like, that this app can make phone call. But well, if that's a desired functionality, that's fine. Then similarly, you have all other stuff listed here. If you scroll down, there is a section here which looks for hard-coded username and passwords. You can do it manually, or you could rely on this tool to find any hard-coded information as well. So let's look at what it has found for us. So on the right-hand side, it's showing you the the code where it thinks that it has found the hard-coded credentials. So let's open it. Okay, nothing so far. Perhaps it highlighted it because it saw these strings like username and passwords. Okay, so what's in the other file? Right, so as you can see here, we have the default database name, we have the default database title, and then a password. So, well, it has found the password, so it could be the password for your local database, which sits in the shared preferences of your APK file. And once you have the password of the database, what you can do, you can pull the database off your mobile device for that particular app, and you can use this password to decompile it. And then you could perhaps see all the contents in that database. So yeah, as you can see, quick and easy, we were able to see hard-coded information. Please feel free to play with this, tool. Have a read. You can find some really useful information sometimes with this tool. But as I said, you have to come up with your own methodology. You have to sort of re-verify all these components. Okay, let's go back to other things. I'm just going to close this off. Right here. And I was talking about you can perhaps view the same code manually as well. Let's go back to our static analysis folder. Sorry. You can see here, there is a Classes.dex file from our very first step. When we unzipped the APK file, we came up with this Classes.dex file. We won't be able to open this file because this is not readable. If I open, I won't be able to open this in JDGUI. Well, I can try. Let's go and say classes.dex file. We want to open it in JDGUI. Let's see what JDGUI looks like. It's a very old looking tool. As you can see, it's not going to open because this is not a supported format by this app. So what we're going to do, so say you have a classes.dex file, there is a tool called D2J or dex2jar tool. So I'm just going to run that, dex2jar. So what I'm going to do, I'm going to pass this classes.dex file to it. So what it's going to do, as its name sort of gives it away, it's going to convert this dex file into jar format, and then we can open this jar file into JDGUI or JetX. So let's see. So let's run. So it's simple. So that's your tool, and that's the name of the file that you're looking to convert. Let's run it. Okay, so it's converting it, and cool, it has done it. Here you go. So it has created a jar file for us. So if it works now, so let's open it up in let's open JDG again quickly. Right, so it's open, and there you go. So it has a Classes.dex to jar. So jar format is supported, as you can see probably here as well. There you go. Now we have the source code of this file, which we can manually review as well if you don't want to use that MobSF tool or other tools that I've talked about. So in Android, in the main activity, which is this one, we can do a manual review by clicking on the main activity. And as you can see, you can perhaps read the source code. You can do searches as well if you're looking for something. So this is another handy tool if you are if you have a DEX file and you are looking to convert and open the source code into it. Okay, cool. So that is done. What else do we have? Cool. We will talk about ADB tool in upcoming slides, but that's all we have for static analysis. Let's see what else. Yeah, so as I was talking about activities, I sort of refer to activities quite a few times. Now, keep this in mind. When you're doing Android pen testing, or you want to learn about Android, just in general, or Android security in general, you just can't blindly go into this platform. You have to have your basics covered, because when you are probably reading through Google's Android project, they have like lots and lots of heavy words. So that's why I just try to sort of break it down for you guys here. So things like the things that you're going to come across would be activities, broadcast receivers, intents, content providers, services. So you actually need to sort of understand before you go into this platform. So let's talk about what an activity is. So in simple terms, any screen that you see on your mobile device, so when you click on an app, that is an activity. For example, let's demonstrate it. Okay, so this is a Android emulator that I'm using. So say I'm opening this app. So the screen that you're seeing right now is one activity, right? So say I click here and go to settings. The next screen that has opened, that's another activity. So I had a previous activity, and then now I'm on a different activity. So these screens that you see in applications are called activities. Okay, so simple, right? Similarly, I just tried to show it here. So you click on the camera icon and then opens up camera. So you launch an activity. Similarly, when you try to click on share, it opens up another sort of display or the window for you. That's another activity, similar to your desktop windows. I hope that clarifies what activities are. Okay, and then you will come across this component called intent. Again, we talked about activities. As I said, let's demonstrate it again. Minimize it, open, first activity, click here, go to settings, second activity. So the communication between these two activities, like the first activity and the second activity, is done through intent. So Android has this component called intent, which is used for communicating between activities. And other things like broadcast receivers and other Android components. So that's what an intent is. There are two types of intents. One is called implicit intent, and second one is called explicit intent. Please don't be confused. So implicit intent is, say you have a photo that you received. You click on the photo, and your phone gives you options saying, do you want to open this photo in these apps? Because all those apps probably support viewing photos, right? So if you see those multiple options, that means that's an implicit intent. But explicit intent is opposite. So what happens when you receive an email? So you click on the email, it opens up in Gmail. Perhaps that's the only app that can support that email viewing. So that is called explicit intent. I will highly recommend following this link if any of what I've just told you confused you. But just keep in mind, intents are used to communicate between different activities. Okay, broadcast receivers. You may have heard me talk about broadcast receivers as well. So broadcast receivers are like broadcast intents. You normally, it's not that your app would automatically signs up for broadcast receivers. So as the name highlights, it's the things that your app has registered to listen for. So for example, say the battery goes low on your phone, all the apps sort of aware of it, because sometimes, you know, maybe the brightness would go down because your the battery is low, and the only reason that app can do it because it has a component or a receiver registered for it. So so the system will broadcast it, and the receiver that your app has registered would listen for that particular broadcast, and then your app would act accordingly. So similarly, say you turn on the GPS on your phone, and you're using Google Map, and your Google Map would automatically knows that, oh, okay, I've listened for that. Now I know that I can use the GPS because you have turned it on. So that is something that app sort of listens for as well. There is an attack as well that can impact broadcast receivers. Again, like, just because of the time constraints, I'm not going to go into too much detail of that, but just keep in mind what broadcast receivers are. Services. Services are just like your Windows services. They don't have, they mainly run on background. You don't really know when the services are running. You can similar to your probably, you turn on a GPS on your phone, it's running in the background. You turn on your location services on, it's running in the back end. So there is no such a user interface where you can go and interact with, similar to what you can do with Windows services. So that's what the services are. The services can be stopped or they may be running. Content provider. You heard me talk about content providers, so let's talk about that. It's like a repository for your APK or your application. It's where your application stores its data, and the content providers could be locally available on your device, or the content providers could also link to some storage that is available on the cloud. So this is where your application stores perhaps its configurations or stores the data that your application needs to run. That's what content providers are. So keep in mind, so say if it's, sorry, another thing to note here, through this content provider, your application can also share data with other apps that are installed on your phone. So, now you see how important it is to protect your content providers. So if you have a malicious app running on your phone, and if you have a very sensitive information about that particular user sitting on your device, and a malicious app can talk to that content provider, it can pretty much fetch everything, right? So another reason why you have to pay a closer attention when you're protecting your content providers. Okay, cool. Dynamic analysis. Okay, that's my favorite topic. As we talked about static and dynamic analysis, static analysis means we are not running the app, we are decompiling the app, we are obtaining the source code of the app, and we are analyzing the app without running the app, okay? So that is what static analysis is. In dynamic analysis, you're actually running the application, and then you're trying to change the state of the app by hooking into the application, or by changing the behavior of the app by, I don't know, maybe you're changing the way a function is returning a value, or you are or you are fetching some variables that application is returning from the memory. So that's what dynamic analysis is. You're actually running the application and you're trying to change the behavior of the app to your purpose, or whatever you want to do with it. Just keep in mind, when you do dynamic analysis, you have to have a proper methodology of what you're trying to achieve with dynamic analysis. Let's talk about what sort of tools we are going to use, or the tools that we have on our disposal when it comes to dynamic analysis. The one that I like to use the most is FRIDA. Free tool. We'll talk about it in upcoming slides. The second one from the MWR labs called Drozer. The tool that I've just recently come across, another tool, is called Runtime Mobile Security, or short for RMS. And the last one, well, I've just listed it here as last, but there are like millions other dynamic analysis tools out there, is called Objection. And these tools pretty much perform the same thing. You know, they are used for dynamic analysis. You're running the app and you're trying to change the behavior of the application. In this talk, I'm only focusing on FRIDA. So, you know, we will only focus on that for this talk, but then I've put references for all the rest of these tools, you know, so you can later on explore these tools. FRIDA, it's a dynamic instrumentational tool written by Ole. You know, he's maintaining, and I think other people are maintaining it as well alongside him. It is used, the way you use FRIDA, you use JavaScript. You can use JavaScript to inject your snippets into a running application. As I said, you could use this tool to instrument how the app is, you know, returning the functions, the values that the function is returning. You could read those values, or you can change the value, which we will see in action shortly. You can read the hidden values. As I said, you can change the behavior of the functions. I would highly recommend, you know, after this talk, if you're really interested in this tool, you go to their website and you just, you know, go through the documentation, as you would learn really greater detail of this tool. And the best thing about this tool is that it's free, and it's and they are updating it on regular basis. What can we use? What are the other use cases to use FRIDA? Well, we can do root bypass detection. We can bypass SSL pinning with it. We can read, modify values that you perhaps can't read or retrieve using static code analysis. You can discover hidden values. In my experience, I have done pretty much all of these while pen testing and while bug hunting, because you could actually see, you know, things like AWS keys being you know, generated on the fly. You can read those using using FRIDA. Sometimes you come across an application that has a root detection enabled, and if I'm using my emulator like Genymotion, like this, because it is already rooted, I may not be able to run my application. So I have to change the behavior of the app so I can run that app on my rooted device. SSL pinning, those of you who don't know, in simple terms, SSL pinning prevents you from eavesdropping on the network traffic between your application and the backend components. The backend components could be the backend server sitting in the cloud, or that application's provider. So, you know, so it sort of prevents you from looking at those APIs and all the middleware stuff. Cool, so what are we gonna do now? FRIDA setup and installation. In my setup, I'm using my laptop. On my laptop, I've got Windows 10 installed. Then I'm using Kali Linux as a VM, and then all the tools are installed inside that Kali Linux. Then I'm running Genymotion as my emulator, which I can show you here. And what you're seeing on the right-hand side is pretty much my Genymotion emulator, which is sort of connected to my my laptop. And the apps that I'm installing are already installed here on my emulator. So the FRIDA server, which I'm going to show you in the next slide, you need to push that onto your emulator, and the FRIDA client will be installed on your laptop. So it's the other way around. Okay. These are the commands that you need to use to run FRIDA and FRIDA server on your emulator. I'm not going to go into too much detail. There are like millions of articles out there on how to set up FRIDA environments and FRIDA labs. So just keep in mind, FRIDA server runs on the emulator, FRIDA client runs on your laptop. Is it a demo time yet? Okay, demo time. Alrighty, so because we've done static analysis, let's do some dynamic analysis. Again, we will go back to our, let's go to FRIDA quickly. What do we have here? Okay, sweet. So I've got this app from MWR Labs. The links are there in the reference section. Just to show you quickly what this app does. It's a vulnerable password manager, right? So I'll just put this password in here just to show you. Sign in. Okay. So here, don't worry about that. So here I've stored my passwords. So let's create another one. So say, I don't know, maybe Gmail, username, root, okay. I'm just creating a quick password just to sort of show you what we're gonna do with it. Save. Okay, so I've got 2 entries in my password wallet now, right? Cool. Let's minimize it and let's open this app again. Just like your any banking app, it just comes up with that, oh, enter your PIN. Okay, if I enter a wrong PIN, it's gonna tell me, oh, your password is incorrect. If I enter the right PIN, it's gonna let me in. Sounds pretty simple, sweet. Let's minimize it again, open it again, and as you can see, the PIN is required. So what we're trying to do now with FRIDA, we are going to bypass the PIN, and we are going to bypass, we are going to brute force the PIN that I'm using here, and I am going to bypass the login using FRIDA. How can we do that? Okay, let's look into it. Courtesy MWR Labs, I've got these 2 files off them. What I'm going to do, I'm just going to quickly show you what I've got here. Oops, sorry. So what I'm doing here, I'm just going to first let's connect to our Genymotion. So I'm running this ADB Connect. That's the IP address of my emulator. Hopefully it's already connected, as you can see. My FRIDA server is already running on my Genymotion. As you can see, I've already sort of ran that in the background. What does that mean? That means if I run this frida-ps-au, it should show me all the running processes or the packages on my emulator. The one that I'm interested in is this. As you can see, the process ID as well, Sieve. Sieve is what? Sieve is this app's name that we are looking to explore. So I can pretty much see all the packages that are available on that device. Okay, let's do it quickly. So what I'm going to do, let's brute force the PIN first. So I've got this. Sorry, let me show you. Gedit PIN. Just going to show you the code quickly, so you know, I don't run out of time. So this is just a Python script. What I'm doing here is I am importing FRIDA and the sys modules, and then don't worry about that. I'm here hooking my JavaScript code into the activity and the function that is responsible for the PIN. So here, because my PIN sort of falls under this range, I've just created a loop here, and then if everything goes well, and if that PIN is correct, and it uses that PIN against that app, it's going to unlock the device. It's going to unlock that application. And at the bottom of this script, as you can see, I'm connecting over my USB, which is the virtual USB, and I'm attaching to the sieve package, right? And it's going to create this process, and then it's calling this JavaScript code here, and hopefully all goes well, and we should be able to brute force the pin here. I would have loved to dive more deeper into this thing, but since we have very limited time, I'm only going to show you the power of FRIDA. So see, I've ran the script now. I'm here, submit, and as you can see, done. It has brute forced my pin. This was my correct pin. And now I have managed to bypass the pin of this application. You can take the same methodology, and you can apply that to your the apps that you may be testing. Like you could look to do how you can change the behavior of the application, right? Okay, so let's close this one. Close this, and let's see if we can bypass the password. Open that. So see, there's a password window now. When we launch the app for the very first time after closing it, it doesn't show you PIN, it asks for the password. So again, I've got another code here for login.py. Don't worry, the code is all available on the internet, and I will provide you all the links. Let's look at that. So here it sort of checks for, the JavaScript code checks for whether the password that I entered is correct or not, okay? How could we change that? Well, if we hook into that method which is responsible for it, we could always return true, because if the check happens, if the password that I enter is not correct, for example, if I type test and do sign in, password is not correct because a function is returning a false value. But if I hook into that function and change the behavior of that function to return always true, I should be able to bypass the login screen here. Okay, with that in mind, this is what the code is. That's exactly what this code does, and we are going to run it. Hope all goes well, and we should be able to, sorry, not gedit. Let's run it with Python 3. We are going to bypass that. Okay, Python 3 login.py. And we hooked into that method. Let's just backspace that. And if I do sign in, let's see what happens. See, so it bypassed the login. Now this time the password login for this application. As you can see how powerful FRIDA is. People have done some awesome work with FRIDA, like they've done things like, bypassing like heaps of things, like, unlocking premium features of the apps and stuff like that. But then again, it all comes down to whether you, have a permission to do so. Okay, I've only got probably 10 minutes, so I'm just going to rush through what else I've got left. Further learning paths, really, really important. In my opinion, if you want to really master the Android application pen testing space, what you really need to do is you have to probably write some apps, like, just for practice, for fun, write your own Android applications. That would just give you the feel that, what components actually make the Android app. I've written like 4 or 5 just for fun, just to sort of clarify in my head what each component means. Learn about Java, Kotlin, and Flutter. You don't have to master these languages, but just learn up to a point where you can read the classes, read objects, read constructors and stuff like that. Flutter is going to be really, really important language in upcoming future, because this language makes it possible to do cross-compilation. So one code can run on Android as well as iOS, and developers love that sort of stuff. Create your own methodology. Come up with a methodology that that you have sort of created. It's like, I don't know, maybe when you're using dynamic instrumentation, that, okay, I'm looking for encryption, or I'm looking for this, and I'm gonna do this, or I'm gonna do that. Come up with something, write it down, have your own methodology. Understand deep linking and schemes are very, very important, People have done some awesome research in these areas. Read up on it, and you will, you will see some really good disclosed reports on HackerOne as well. Practice on purposely vulnerable application. Well, there are heaps of them. I provided links in the references. Go ahead, create your own lab and practice on those apps. It's for fun. Read FRIDA documentation if you want to dive more deeper, and follow these people. The last one is mine, but that's fine. You can choose not to follow me. But these guys have done some awesome jobs for Android pen testing space. You can go follow them. They have awesome YouTube channels, and as well as their articles as well. Some useful links. Please go through these links. Everything is hyperlinked there. Protecting your app. As I promised, the last section is focused on the blue teamers, how to protect your applications, and what kind of measures you can put in place to make our life harder. First of all, make sure, before I don't even look at the slide, first of all, make sure that you have root detection enabled on your app. Make sure you have SSL pinning enabled for your app, and try to minimize or try to obfuscate the code that you have written. You can use things like, a code obfuscator. There are some premium versions of these, like ProGuard. ProGuard takes this code and converts it into this. So it just makes life harder for reverse engineers when you have the code which is minified up to this level. It's really hard to make sense of this code. So that's why it is really important that you minimize your code, your source code. Make sure that you don't store sensitive information on your application source code. I've seen so many apps, people are leaving behind API keys. Their consumer secrets and username secrets. I've seen username passwords hard-coded into it and all other stuff. You would come across heaps of things. So yeah, please don't do that. Make sure all the important components of your app is sort of offloaded to the server side. So you don't really store that on or hold that on the client side or in your application. What else? There is always a way, there is a code that you can write within your apps, which would instruct the app if the app is attached to a debugger. So if you are doing a real-time debugging, for example, I'm hooking into FRIDA, or I'm running a GDB or something against the APK, if you have that anti-debug code written into or injected into your APK file, then the application should go into a limited state. It should not disclose or let you explore all of its features. So these are the things that you can put in your Android application, because obviously that will make an attacker's life really harder. Having SSL pinning would obviously add another layer of defense for you. Again, it's not a bulletproof solution, because in spending enough time, it is possible to bypass pretty much every defense, but it's just going to make life harder for someone who's looking at your applications. Don't store hard-coded stuff in your content providers. Don't leave your content provider unencrypted. Make sure it is encrypted, and the encrypted key shouldn't be hard-coded into your application, right? Because obviously, as I said in the beginning of the talk, that if you are leaving the encryption key there, like we found in the static analysis, someone can take that key, can decrypt your content provider, and can pretty much see all the information that is being stored there. So please don't do that. That's pretty much it. These are all the references and the tools that I talked about. Please feel free to go ahead and visit these links, and I hope you have found this talk useful. If you have any questions, please feel free to hit me up on my Twitter. I'm active on YouTube. Our organizers know how to reach us. Thank you. Well, that's me.
Thank you for the amazing talk about Android pen testing. It was really
thank you.
Really great quality, clear voice. Sleeps very good.
Thank you. Appreciate it.
And the demo was good. I see a good response from the people who are watching.
Thank you.
And there's one question from someone. Can you share a brief summary about your approach to application for pen testing and application?
Yep, sure. Good question. So my methodology is when I come across a mobile application, so I will say, for example, I have an app. I will have my app installed in an emulator like Genymotion, for example. And then what I do, I will pull the APK off the Android from my emulator, and then I will, first of all, I will do static analysis. I will just look for hard-coded keys, hard-coded secrets, anything that is hard-coded based on the regex that I've created. I would look for that. I will feed that to MobSF as well, just so I have multiple tools doing the same thing. And in case if I missed something, then after that, once I've done my static analysis, I would go in the application and will try to understand the behavior of the application. And then once I understand how the app works and stuff, then I would go back to the source code of the application to see if there is any interesting function that I could use or that I could hook into FRIDA to change its behavior. What we saw in the demonstration that, if you come across an app that has a pin or something, then obviously you may be thinking that, oh, is there a way that I could actually bypass that pin? But then again, that depends on the logic of the source code. So you could go back and you can and can see whether you can there is an ability to hook into it. So again, as I said, everyone has a different approach. My approach is to start with dynamic analysis and I then move into dynamic analysis. And that's when I start to do more of my source code review, as I showed you, how to convert a DEX file into a jar file and then sort of start reading the code. That's my approach. Thanks.